Bright Tuty. Every student matters.
Hello students, this is the second topic of your chapter and the name of this topic is chemical changes. We have already studied what physical changes are, right? We discussed that physical changes are reversible, most of them are reversible, and there are no new products formed. In physical changes, there is only a change in size, shape and state and sometimes color of the object, right? There is no change that is irreversible. But in chemical changes, the characteristics are just opposite. First of all, there is an irreversible change, right? There are new products formed, and the change that occurs is a change in the chemical properties of the substance. Basically, during chemical changes, chemical reactions occur. Chemical reactions occur. We will be studying about chemical reactions now, right? So here chemical reactions occur. So what are these changes? Let us discuss some examples. The first one being rust and rusting. Students, you know about iron articles, right? There are iron objects all around you. Now what are these objects basically? Iron objects can be nails, right? Any railing you are walking across, right? Any handles, right? So all these, there are some instruments, utensils as well. So as you can see, there is a picture of nails in front of you, right? You use these nails, you fix them up in a wall and then you hang things on the nails, right? So what are you noticing? You must have seen this kind of powdery brown substance covered on that covers the iron articles. What is this powdery brown substance? This powdery brown substance is the rust that I'm talking about. It is rust, right? Rust, basically, if you call it in Hindi, it is jung. Jung lagna is what is rusting. So rusting is jung lagna. It majorly happens with iron articles. Now what is happening here? Basically, these are iron nails. So we can say that what the change that is occurring is a chemical reaction. What is happening? The iron, right, reacts with the aerial oxygen. Aerial oxygen means the oxygen gas present in the air and the water present in the air. Water is basically moisture. It is in the gaseous form, not in the liquid form. You can say it is water vapor, right? It reacts with water vapors and aerial oxygen to form iron oxide, which is Fe2O3. You can say this is iron oxide, and this is the rust. Rust is basically iron oxide. So what do you see? What is happening? Can you obtain the iron back again from the rust? See, what happens is this rust destroys the article. Right? You cannot obtain the amount of iron wasted due to rusting back again, right? It cannot be reversed. So first of all, it is a chemical change, right? It is not reversible. You cannot obtain the iron back. The iron that has been converted into rust cannot be obtained back. And also, new products are being formed. The new product here is rust, right? And this procedure of development of rust on iron due to the reaction of iron with the oxygen and moisture present in the air is known as rusting. We will be studying this in detail in the third topic, which is totally on rusting, but I just have to tell you that rusting of iron is a chemical change. It involves a chemical reaction. It is irreversible and a new product, that is iron oxide, is formed during this reaction, right? So this is a chemical change. Coming to the next example, burning of magnesium ribbon. What is happening? Basically, you have magnesium metal in the form of a ribbon, right? You have taken a ribbon of magnesium, like a thread. For example, you have taken this much part of magnesium. It is made up of magnesium and this is a wire or ribbon, you may call it. Now what happens during burning? Burning is basically combustion, right? Combustion occurs when any substance reacts with the oxygen present around it. So magnesium is reacting with the aerial oxygen, right? In the presence of heat. How is this happening? Where is this heat coming from? You are using a burner, right? This is the flame of the burner, and you are heating the magnesium ribbon on the burner. So you are supplying heat. Then what happens is magnesium reacts with oxygen to form a powdery substance. To form a powdery substance which is white in color. What is this substance? This substance is magnesium oxide, right? And it burns with a dazzling white flame. This is a property. So what happened here actually, if you can understand, you had initially only magnesium ribbon, right? You started burning it. So when you started burning it, it started reacting with the oxygen present in its surrounding. Now students, you have to understand that oxygen gas supports fire, or you can say it is the only element which supports fire. In fire extinguishers, we use carbon dioxide to put out the fire. So carbon dioxide does not support fire. So whenever there is a fire happening, it means that there is a lot of oxygen present around that substance. That is why the fire is continuing. So oxygen supports fire. So when magnesium reacts with the oxygen, it forms a white powdery ash substance, and this ash collected is a compound that is known as magnesium oxide. This is white in color. Alright. So what did you notice? First of all, from this magnesium oxide, this wire cannot be obtained back. You cannot obtain this wire back again from the magnesium oxide. So first of all, it is an irreversible change, right? It is an irreversible change, and a new product, that is the powder, a new product is formed, right? So these are the two characteristics that makes it a chemical change, and there is a chemical reaction occurring as well, right? A new substance is formed and there is a chemical reaction behind it. So this again is an example of a chemical change, right?
Take a magnesium ribbon about 10 centimeters long. Hold the magnesium ribbon in the fire tongs and heat its other end in Bunsen flame till it catches fire. Hold the burning magnesium ribbon over a glass plate. You observe that magnesium ribbon burns with a dazzling white flame and forms a white residue which falls in the glass plate. Actually, the magnesium ribbon enters in a chemical reaction with oxygen present in the air to form magnesium oxide. Following conclusions can be drawn. Magnesium on burning in air forms a new product, magnesium oxide. The change proceeds with the evolution of heat and light. The change is permanent and irreversible. Now collect the white ash, magnesium oxide, and drop it in a beaker containing about 20 ml of water. Stir the water thoroughly and test it with red litmus paper. You notice that litmus paper turns blue. This shows that on dissolving magnesium oxide in water, a new product is formed, which is basic in character. Actually, the magnesium oxide enters into another chemical reaction, forming magnesium hydroxide, which is basic in character. Change in color of copper sulfate solution with iron nail. Materials required: beaker containing tap water, copper sulfate crystals, dilute sulfuric acid. Method: take a beaker and in it pour 50 ml of tap water. Pour 1 to 2 spoonfuls of copper sulfate crystals in the beaker and stir well. Add a few drops of dilute sulfuric acid. You obtain acidulated copper sulfate solution. Take out about 5 ml of the solution in a test tube for comparison. To the rest of the copper sulfate solution in the beaker, add 2 lightly polished iron nails. Cover the beaker with a paper and leave it undisturbed for half an hour. Now compare the color of copper sulfate solution with the test sample in the test tube. Take out the nails and observe their color. You notice that The blue color of the copper sulfate changes to light green color. The brightly polished iron nails are coated with a reddish-brown deposit. Actually, the copper sulfate solution enters a chemical reaction with iron nails to form new products, that is, iron sulfate and copper. The iron sulfate solution is green in color, whereas the reddish-brown residue on the iron nails is of copper. Following conclusion can be drawn from the above reaction. New products are formed. Change in color takes place. Change is irreversible and permanent in nature.
Now the next activity. What you have to do is, you have to take a teaspoonful of vinegar in a test tube, right? You have taken vinegar and add a pinch of baking soda to it. You have to add baking soda to it, right? You would hear a hissing sound and bubbles of gas coming out. When you put vinegar in baking soda, basically what happens is carbon dioxide is released. Carbon dioxide is released as a product of this reaction. That is why you hear a hissing sound, right? There is an effervescence, brisk effervescence. Bubbles are seen, as you can see in the picture, these are bubbles. So this gas comes out of the solution as a reaction, and then you pass this gas from a freshly prepared lime water solution. This is lime water, right? This is lime water, and lime water is basically calcium hydroxide, and you are passing carbon dioxide through it. Obviously, because you need to produce carbon dioxide, you took this initial apparatus to produce carbon dioxide only. The use of this apparatus is only to produce carbon dioxide. You do not have to learn the exact reaction of this first initial stage. You just have to learn that this apparatus releases carbon dioxide. Now when this carbon dioxide is released and passed through a freshly prepared lime water solution, this lime water turns milky. It was colorless or transparent earlier, but when you pass carbon dioxide, it turns somewhat white. It turns milky, it looks like milk. So what has happened? What change did occur that it made the solution milky? Basically, what happened is, as I told you, the vinegar and baking soda in the initial stage in the test tube 1 reacted to form carbon dioxide and other substances which are in the test tube itself. Test tube contains the other products. The product that we need is carbon dioxide. So carbon dioxide is then passed through lime water, right? So carbon dioxide is passed through lime water. What does it produce? It produces calcium carbonate and water. These are the products formed, right? This is the chemical reaction. The reaction basically proceeds to form calcium carbonate and water. Now these are the new products formed. New products are calcium carbonate, and this calcium carbonate is milky. Is basically a white compound, white precipitate you can say, because it does not dissolve in water. It will settle down after some time. Precipitates are the insoluble substances formed as a product in the reaction, and it will settle down. But when you pass carbon dioxide initially through lime water, it turns milky because of the formation of calcium carbonate, right? This is a milky substance, and water is formed as a side product. So what does this tell you? That this is again a chemical reaction. You cannot obtain lime water or carbon dioxide back from this solution, right? Because the reaction has occurred and this is a chemical change with the formation of new products and an irreversible change. So this is again a chemical change, right? So what did we learn till now? Let us see the definition of chemical reaction. A change in which one or more new substances are formed is called as a chemical change. Simple. Till now we saw that there were many new products being formed. So a change in which one or more new substances are formed is called a chemical change. Alright. A chemical change is also called as a chemical reaction. So chemical change is basically a chemical reaction occurring. Chemical reaction tells us the detail. Chemical change only tells us that there is a chemical change happening, right? Chemical reaction gives us the details of the change, right? So these were some chemical changes that we learned about. Now we have to understand the importance of chemical reactions. What are the importance? All new substances are result of chemical changes. What are these? For example, we have plastic, we have food, right? All these are produced due to chemical changes. As I told you, cooking of food is a chemical change. So chemical changes are very important to us, right? Because new substances, whichever new substance is formed, is due to a chemical change happening, right? For example, we have curd also. Curd is obtained from milk, and this is a chemical change, right? Now to extract metal from metal ores, this is again a chemical change. You will be learning about it in detail in class 10th, but you have to understand that this is a chemical change. Now producing medicines, we have some initial ingredients, right? Or you can say chemicals, and then they react with each other to produce new substances which are medicines. So producing medicines which are very important for us are produced due to chemical changes, right? Then plastics, detergents, soaps, all these are also formed due to chemical changes only. All these are formed due to chemical reactions, you can say. So these are very important for us, right? These are simply very important. Then changes that follow a chemical reaction. What might also happen when a chemical reaction is occurring? Heat and light may be given or absorbed. In the case of burning of magnesium ribbon, what did you see? You saw that it was burning with a dazzling white flame, right? It had a very bright flame. So light was being released. Heat was also being released. So these are some changes that occur during a chemical reaction, right? And heat may be absorbed as well. There are many reactions in which heat is absorbed. So there are different kinds of reactions, and there are different kinds of changes in case of heat and light in every reaction, right? Then sounds may be produced. As we saw when we produced carbon dioxide in the experiment where we passed this carbon dioxide through lime water, when carbon dioxide was produced, it produced a hissing sound, right? This hissing sound is a change that follows the chemical reaction. The production of carbon dioxide is accompanied with the hissing sound, right? So this is again a change followed by the chemical reaction. Then change in smell or a gas production. Yes, definitely. Gas production and change in smell, because certain gases have certain smells. For example, sulfur dioxide has a very peculiar rotten eggs like smell. It is a very bad smell, and whenever sulfur dioxide is released, you can understand that because of the smell that it has, right? It has a very peculiar rotten eggs like smell. So these are some changes which are accompanied by the chemical reaction. And also change in color. As you saw in the example of copper sulfate and iron, the solution turned from blue to green, right? This was because of the chemical change, and you saw color change. So these are some changes followed by chemical reactions. Now burning is always a chemical change. Whenever you burn, it is always a chemical change, and it forms new products, and the initial ingredients or the reactants cannot be obtained back. For example, when you burnt the magnesium ribbon, you had magnesium, right? It formed magnesium oxide by reacting with oxygen, right? Can you obtain magnesium back from magnesium oxide? No, you cannot. It can never be obtained. So burning of magnesium is a chemical change. Then burning of wood or leaves. When you burn wood, it turns into coal-like substance, right? You cannot obtain the wood back from the coal, and you cannot obtain the leaves back from the burnt leaves. So burning of wood is also again a chemical change. Now it is always accompanied by production of heat. Whenever you burn a substance, the substance burns and changes into different products, but it also always releases heat. So it is always accompanied by production of heat. As we saw in the case of burning of magnesium ribbon, it produced a lot of heat and light. So it is always accompanied by production of heat. and then burning of explosions. Basically, we are talking about firecrackers. What happens in firecrackers? When you light up a firecracker, it goes up in the sky and it burns with a lot of heat and light. Right? It releases a lot of heat and light in different patterns. So this is again an example of a chemical change occurring because of burning of a substance which is explosive in nature. Right? So these were some characteristics of chemical changes and burning of substances. Now when food gets spoiled, it produces a foul smell. Is it a chemical change? Yes. Whenever food is spoiled, it changes into something else, a rotten substance, basically rotten food, and you cannot obtain the good food back from it. It cannot be obtained. The good food that was present earlier cannot be obtained back from rotten food. So yes, the spoiled food is obtained due to a chemical change. A chemical reaction occurs due to the oxygen present in the air, right? And it is spoiled then. So it is a chemical change. Then can we call photosynthesis a chemical change? Yes, photosynthesis is also a chemical change. What happens during photosynthesis? The plants use carbon dioxide, water and sunlight, right, to produce their food, which is glucose. Right, they produce their food. Now glucose is not converted back into carbon dioxide or water. It is basically a chemical change. So you have to understand what chemical changes are, right? So what did we learn till now? Basically, carbon dioxide is a gas present in the air, right? And water is obtained from the soil by the plants, right? You have understood photosynthesis already. And it uses sunlight. The plants use sunlight to produce glucose, which is C6H12O6. This is the formula of glucose. This is produced as a result. And this is a new product, right? This is the food that is utilized by plants. So yes, photosynthesis is also a chemical change. Then students, Paheli said that even digestion is a chemical change. Definitely digestion is a chemical change. You intake food in your body, right? When the food goes inside, it is utilized by our body. It is broken down into simpler substances and then utilized by our body, and the waste is then removed, right? Waste is then removed from our body. So even digestion is a chemical change. So all these changes that we discussed are chemical changes. And students, so another thing that you have to learn is about ozone layer. Let us read carefully. You must have heard of the ozone layer in our atmosphere. Yes, ozone layer is a layer present in our atmosphere. It protects us from the harmful ultraviolet radiations which come from the sun. It protects us from the harmful radiations coming from the sun. For example, this is the earth, this is the ozone layer, and this is the sun, right? So this ozone layer basically does not let the harmful UV radiations enter inside the atmosphere. Now ozone absorbs the radiations and breaks it down into oxygen, right? When ozone absorbs this radiation, the ozone, which is O3, basically absorbs the radiation and forms oxygen gas, which is O2, right? There is a difference. Ozone is O3 and oxygen is O2. So ozone absorbs the radiations from the sun and breaks down into oxygen gas, right? Can we call the breaking of ozone layer a chemical change? Yes, because oxygen then does not combine to form ozone. You have a new product formed. Ozone was O3 and oxygen is O2. Obviously there has been a chemical reaction and the new products have been formed. So if ultraviolet radiation were not absorbed by ozone, it would reach the Earth's surface and cause harm to us and other life forms. The harmful radiations are very dangerous to us. They can cause different skin diseases, different cancers of skins. So ozone layer is very important to us. So ozone acts as a natural shield against this radiation. So we have to protect this ozone layer as well. The ACs that you use, the ACs basically utilize chlorofluorocarbons which are harmful for our ozone layers. So the ozone layer. So we have to utilize ACs and refrigerators as less as we can because they can harm our ozone layer. So this was the second topic of your chapter in which we talked about different chemical changes. Thank you for your attention, students.